Hey, this is Brett with ISW. Today's video is for anyone who operates or is opening a new restaurant, sports bar, arcade, or any other venue that has a need for a high volume of TVs, displays, or video walls. This video is also for the AV integrator or video system engineer that might be currently using IP-based distribution or is considering making a switch. When deploying a high number of screens for watching sports, digital signage, live events, and general entertainment, you're going to face some challenges that you may not typically encounter in a smaller venue or at home. Distributing video not only to many screens, but also over long distances and in a way that's easy and simple to operate is a common challenge that bars, nightclubs, arcades, sports bars, casinos, etc. face. Often, we hear that newer IP-based solutions, also known as AV over IP, can help you save money and complexity. But does it really? Or is it just a marketing tactic to get you to throw away your old matrix switches in favor of something new? Today, we're going to conduct an experiment to find out if it really is cheaper and simpler, or if that's just marketing fluff. We're going to get in some real numbers and talk real dollars. So, if you're in the hospitality business and you want to understand if this will save you money, or if you're an AV integrator who's flirting with the idea of AV over IP, and you need to find a way to make a tight budget, then this video is for you. When taking a look at this experiment, we wanted to first establish a number of constants that we will apply to both an HDMI-based system and an AV over IP-based system. And you can see those constants here before you. The first of which is the quality of the video and the AV that we want to be distributing within our venue. And that up here, what's known as 4K 60 FPS 444. What that means is it's a 4K resolution. You can Google the exact number of pixels and the dimension that's native to 4K. 60 frames per second essentially equates to looks really good in slow-mo. 444 chroma subsampling. This has to do with the way that colors and resolution and contrast shows up. We also are going to be discussing the distribution amongst 60 displays. And those displays in each scenario are going to be Samsung QMC digital signage. As for our audio and amplifier channels, we're going to be discussing PowerSoft Unica amplification. It's their new cloud-based amplification platform. As far as AV sources, looking towards the left here, we're going to be taking a look at a total of 6 Apple 4K TVs and 3 BrightSign XC5 media players. As far as cabling and connecting your rack to your displays, we're going to be presuming that in both cases, we're going to use Belden 10GXF, that's Cat6A FUTP plenum cable. It's good for 100 meter runs and up to 10 gigabits of bandwidth. Finally, we're going to go ahead and assume that all the products being looked at here are at MSRP. I know that oftentimes MSRP is not always upheld. There's the whole concept of minimum advertised pricing. You may even find a better deal in that. But for purposes of comparison and consistency, we're going to be looking at MSRP. Those numbers are always readily available. So that's what we're going to proceed with today. Let's take a look at the signal chain. First, let's take a look at the signal chain for an HDMI-based video distribution system where we have 60 displays and 40 amplification channels. As we mentioned before, our HDMI 4K sources are comprised of 6 Apple 4K TVs and 3 BrightSign XC5 media players. These BrightSign XC5s are capable of a single 8K output or 4 4K outputs. For the purposes of this comparison, we're going to operate them in 4K mode, meaning that they're each capable of distributing 4 4K streams of media. Our third BrightSign player is actually only contributing 2 of its 4 potential streams. So just keep that in mind. Before we take a look at these distribution amplifiers, let's go to the core of our system, which is the AV Pro Edge 16x16 4K HDMI matrix switches. As you can see here, each of these matrix switchers has a series of inputs and a series of HDMI outputs. It also has balanced audio outputs, which we're going to use in this scenario. Why do we have 4 of them? These are fixed architecture matrix switches. You have 16 HDMI inputs and 16 total HDMI outputs. But we have 60 displays. 16 is not going to cover 60. So in this scenario, we need to ensure that we have enough coverage for all 60 of our displays. And that's why you see 4 of them here. 16 times 4 is 64. That covers all 60 displays that we would need, with room to add 4 more at a later date if necessary. Let's go back over to our sources and think about how we're going to take the 16 sources that we have and provide and offer them to all 60 displays. The most that we could do without the use of an in-between step between the sources and the matrix switchers is assign, say, 4 of our sources to each matrix switcher. But that would mean that our displays can't actually display all of our potential sources. So to solve this challenge, we have to add a device in between known as a distribution amplifier. And in this case, as you can see, we have a 1-to-4 HDMI distribution amplifier for each of our 4K sources. Zooming in, you can see that it has a single HDMI input, which you would connect to any of your sources, and then it has 4 outputs. And in this scenario, we would take each one of those 4 outputs and connect them to one of our inputs on our 4 HDMI matrix switchers. So now that we have our video into the system, as we mentioned before, we're going to be using distributed audio. We're going to have different audio zones for different areas within the venue. And to do this, we need to get that audio out to amplifiers. So as we mentioned before, you can see all of these different terminal blocks at the top of the matrix switchers. These are going to be the audio out for all 16 of the HDMI inputs. And this audio out is going to be sent down into a BSS Blue 160 fixed architecture DSP processing system. What it means is that ultimately we have a fixed number of inputs and a fixed number of outputs. In this scenario, we need more inputs and certainly more outputs to cover all of our AV sources. So to have enough coverage, we actually have to use 2 Blue 160s, and to ensure that we have enough channels for our 40 amplifier outputs with the PowerSoft Unukas, we also had to add an additional 2 Blue Bob 2 breakout boxes from BSS as well. So that's 4 total rack units for audio processing that will be sent to our amplifiers, as well as 4 total rack units just for the HDMI matrix switching. So now that our audio has been routed out to our amplifiers, and now that we have the ability to send any one of our AV sources to any one of the 60 displays, how are we actually going to get them from within our AV rack out to the displays at the far end? To do this, AV Pro also provides a solution, and they do it at different tiers. Now, what's important is that we used a solution, an HD-based T extender, that is capable of not only 444 chroma subsampling, but also can extend out to 100 meters, which is going to match the rating that we have on the AV over IP side, as well as the type of cable that we're using, that Belden 10G XF Cat6A. And so you can see here, each one of our HDMI outputs is corresponding to exactly one of our HD-based T extender. These are the transmitters. If you zoom in, you can see, of course, that you have an HDMI in, you have an Ethernet connection, and then you have an HD-based T port out. Now, these HD-based T ports are going to be connected to that Belden 10G XF Category 6 cable, and they're going to leave the rack and they're going to go out to front of house through the walls, through the ceiling, through conduit. And at the other side of that, where our 60 different displays are located, we're going to affix an HD-based T extender receiver on the backside of the display. So these blue wires in between indicate where we're going to be using that Cat6A. And now we transition back over to the red side, which is going to be our short HDMI patch cable. So that covers the entire video distribution signal chain for HDMI. One thing that you probably are noticing is just how much cabling is going to go into this. Each one of the red lines represents some type of either HDMI or microphone cable. In the case of the audio distribution, that is going to be microphone cable, which is analog. All the other connections in the space, we're looking at HDMI patch cables. Now, if I pause for a second, really think about not only the cost of the system, but the cost of the space of the system and how fixed the architecture is. We're talking about 8 rack units just to perform matrix switching functionality. We're talking about 60 extenders that have to be located somewhere in the rack. Now let's take a look at the AV over IP video distribution system with 60 displays and 40 amplifier channels. For me, this is far more satisfying, and yeah, I can sigh. I can let go of the anxiety that I feel when I look at the HDMI system. Let's again start on the left-hand side. We have the exact same 4K sources that we mentioned before. Now, what you'll probably notice immediately is that we have 3 network switches. We'll get into those in a minute. We still have our 40 amplifier output channels through PowerSoft Unica, and we still have our 60 QMC digital signage displays from Samsung. This is AV ProEdge's MXNet Evolution 2. The entire switching functionality is done with its control box. It's a single, very small rack unit that can handle, I'm going to fact check myself, somewhere around 250 different HDMI inputs and encoders and decoders. Now, in addition to the control box, you can see here that each one of our sources is corresponding to one of these 1 gig EV2 encoders. And these encoders have the ability to send a Dante stream. And that is what we're going to be using in the spirit of IP-based audio and visual distribution systems to send our audio signal to our amplifiers. Coming out of these encoders, we now have AV over IP. And specifically in this scenario, we're using a JPEG 2000 compression algorithm. Each of these encoders and the control box is going to be connected to a 1 gigabit switch. In this case, it's a Netgear GSM 4248PX to be exact. It's got 41 gig ports, PoE plus in all of them, and 8 SFP plus ports for trunk and lag links between switches and between the router. So we've got all of our inputs and our control box connected here, but what about all of these extra ports? Each one of those represents a home run out to one of the decoders that's going to live on the back of the displays. So you can see here, we have all 60 MXNet 1 gig EV2 decoders that are going to be on the back of the displays. Now these decoders don't have Dante, and that's because they don't need Dante. Why? All the audio is staying within the rack and it's going to those PowerSoft Unica amps. And then from there, the speaker cables will run out into the front of house. So ultimately, instead of having 4 BSS components and 4 HDMI matrix switchers, we have a total of 3 network switches that not only can be used for this application with video and audio VLANs, but can also be used for a whole host of other AV needs and tasks like CCTV, Wi-Fi access points, and others. One more time, our 4K AV sources get encoded through a short HDMI patch cable. They then connect directly to the network switch and go out of the AV rack into front of house through that Belden 10G XF Cat6a cable to each display, which has a decoder on the back. All right, so now that we've taken a look at the network and the architecture of the HDMI system versus the AV over IP system, let's get to the good part. Let's look at the price comparison between the two systems that we just saw. All right, so the HDMI distribution system with 60 displays that we just saw has runs between 30 and 75 meters. Here is the MSRP for all the products that we just saw. The HDMI matrix switchers, the 16x16 version, we needed 4 of those. Those come in at an MSRP of $13,439 a piece for a total of $53,756 just to distribute the video. If you remember before, we needed distribution amplifiers to ensure that all of our displays could showcase any of our sources. Those 16 distribution amplifiers each retail for $439 for a total of $7,024 MSRP. Requiring the 100 meter 444 kits for the HD-based extender, transmitter, and receiver, we need a total of 60 of those kits. They each retail for $2,029 for an MSRP subtotal of $121,740. Getting down into audio with BSS, we mentioned those breakout boxes. We needed 2 of them, $1,074 a piece for an MSRP of $2,148. And the processors themselves, the Blue 160 fixed architecture, $4,839 a piece for a total of almost $10,000. And lastly, and something that we didn't exactly touch on, but all the HDMI cables that were in that system, of course, need to be purchased, and they do add up. We needed 140 HDMI patch cables for that system, utilizing 2-meter cable to go HDMI patch cable. Each retails for $36.99 for a total of $5,178 MSRP for patch cables alone. As you can see here, the grand total is nearly a whopping $200,000 MSRP for an HDMI distribution system. All right, AV over IP distribution, the same 60 displays, the same 30 to 75 meter distances. Let's break it down. So unlike those 4 HDMI matrix switchers that each cost $13.5K, the one very small unit that can control all of this AV over IP distribution is that control box within the MXNet ecosystem from AV Pro Edge for a total of $809 MSRP, and you only need one of them. Alongside that control box, we looked at those encoders that also split out Dante for the A over IP. Each of those retails for $1,539. We needed 16 of them for $24,624 MSRP. From here, we're taking a look at those decoders. There's really no way to scale those. You need one on the back of every display. This is the bulk of the cost in this system. $1,469 MSRP for $88,140. With HDMI, we had 140 patch cables. Now we only need 76. We brought our cost down to $2,811.24 MSRP. In the HDMI-based system, we didn't need any network switches. We need 3 of them here. The 48-port switches with PoE Plus each have an MSRP of $4,804.58, and the 24-port $2,963.86. We needed 2 of the larger switch, 1 of the smaller one, for a total of $9,609.16 and $2,963.86 respectively. In total, the AV over IP distribution to produce the same quality picture over the same distance to the same number of displays is $128,957.26. So you can probably tell that AV over IP is cheaper in this scenario. AV over IP is actually 35.37% cheaper than the HDMI-based version. This is real cost savings for your client, and this is real budget that could be allocated to other things within the ecosystem, like loudspeakers or chandeliers or employees. Now, I can hear what you're saying now. 60 displays is way more than my venue. I'm not going to have 60 displays. Conversely, you might also say that, oh, I have way more than 60 displays. If we scale this down, what do these numbers look like? Is there a break-even point? And how does it compare to something that's much smaller? Before we take a look at the numbers, I want to remind you one more time of this HDMI matrix switcher, because it's going to lead us to the next piece of this presentation. It has 16 4K inputs, which match the number of AV sources that we have, and 16 HDMI outputs. So what we're going to do is we're going to bring the number of displays from 60 down to 16. All right, so let's take a look at the HDMI distribution with only 16 displays with distribution runs from 30 to 75 meters. As we mentioned before, we're going to be looking at a scale that only requires a single HDMI matrix switcher. That's still the AC-MX1616. It still retails for $13,439 MSRP, but we only need one of them. So our subtotal is going to be $13,439. Now, a key difference here that you may remember from the last time, we no longer need any distribution amplifiers. Because we only have 16 total displays, all 16 of our AV sources can be fed directly into that HDMI matrix switcher. So none of those distribution amplifiers are in this spec. We still have the 100 meter 444 HD-based T extender kits, but because we only have 16 displays and not 60, we only need 16 of them. So that's going to be, again, still $2,029 MSRP for a total of $32,464 MSRP. Now, in a 16 display system, I think it's fair to say that we'll probably have less overall audio zones and have a smaller need for audio output channels on our amplifiers. So what we did is we went ahead and assumed that we could fit all of our audio on a single blue 160, which retails for $4,839, and this time we only need one of them. And finally, instead of 140 C2G HDMI patch cables, we only need 48 for a grand total of $1,775.52, down from more than $5,000 in the first example. The total here is $52,517.52 for all this gear, assuming MSRP. Okay, Here we are, AV over IP distribution, only 16 displays. We still have the control box, which retails for $809 MSRP, and we still need just one of those. We still need the same number of MXNet 1 gig EV2 encoders with Dante. They're still 1,539 MSRP. We still need 16 of them for $24,624. We've reduced our decoder net needs down from 60 down to 16 for a total of $23,504. Patch cables, this time we only need 32 of them for $1,183.68. Switches, we no longer need 3. We can get away with 1. We only need approximately 32 ports for our distribution system, maybe 33 ports, and we can actually use the rest of those for our Dante amplifier channels for a total of $4,804.58 MSRP for a single switch. Maybe to your surprise, AV over IP is actually 4.58% more expensive than HDMI when we're only talking about 16 displays from 30 to 75 meters, according to the constants that we ran this experiment in. All right, so to wrap this up, at scale, I think AV over IP has obvious cost benefits. In a smaller system, the cost is more similar, and we picked 16 displays specifically because I thought it would be most challenging to this principle. If the owner or the integrator wants to add one single more display into that system, they're going to immediately have to spend another $13.5K to buy another HDMI matrix switcher, and they're going to have to start buying distribution amplifiers. So this is a razor thin margin. There's absolutely no ability to scale. And for those reasons, for the flexibility, for the future-proof nature of AV over IP, for the scenario where the owner wants to just simply add in 2 more displays, they can do that without buying virtually any other hardware besides the display and the decoder, of course. It's a much higher probability that you're going to have to buy a larger rack or additional racks, not to mention all of the time and labor that goes into programming all of these additional devices, cable management, and installing them. Finally, another big benefit of AV over IP are those network switches, because they're not dedicated for this purpose. As you can see, they can distribute AV over IP. They can distribute Dante and other A over IP protocols. They can be used to connect your point of sale systems. They can be used to power and connect wireless access points, CCTV. They can power loudspeakers, lighting, and many other things. For all these reasons, in my business, I would still go with the AV over IP in this scenario, knowing that future scalability, flexibility is worth the additional 4.58%. Hey guys, so that wraps it up for this video. In my opinion, AV over IP is a clear winner as soon as you start getting to sort of any substantial scale in the distribution of your AV over IP. I know for some AV professionals, it can be a little scary. Ultimately, for clients, they really don't care what's happening underneath the hood. They just want it to be a cost-efficient solution. And when they change their mind, when things need to be flexible, they don't want it to cost an arm and a leg more to make those changes and those updates. And finally, everything has to be easy to use. You can achieve that in both of these systems. But again, some of the flexibility and customization with the AV over IP system makes it a winner in my book.